In these videos, we're going to talk about financial mathematics. We'll talk about a few different types of accounts that may be offered to you in the real world, like regarding loans for cars or student loans, bonds and savings, credit cards. There's these annual percentage rates that come up a lot, or APR for short. And it's good to understand that with certain compounding methods and certain annual percentage rates, what really is the best deal for you. Because a lot of banks will try to pull a fast one on you. And with these formulas that we get in this section, you can actually check the math behind it and know what's the best route to go. So there are a lot of different forms of calculating these. This first one we're going to look at is simple interest. And with simple interest and compound interest, something I'm going to show you is just a breakdown of what happens year to year with the formula and kind of give you a structure for it so you can see where the formula is coming from. With these examples here and in the next video, you won't need to recreate these formulas, but just to give you a foundation for, instead of just giving you the formula and plugging in, how does that form? So, simple interest. Interest that is only earned or paid on the original amount. So what we're going to focus on is what did we originally deposit into the account. So we're going to have this initial deposit, which this initial deposit that we put into an account, we often call this the principal. So we'll see that terminology come up in these sections. But this principal deposit that we put in and then gaining some percentage on that. So for example, let's say we invested $500 and we're going to earn 6% interest every year on it for 5 years. So there's a limit to this account that we're using. So the key is that each year, the 6% interest is only on that initial amount. So we're really going to focus on this 6% of 500, and that's the amount that we'll add on each year. Now, taking a percentage of a whole, that'll come through as multiplication, so we'll have to use the decimal form of our percentage, so 0.06 times 500. If we plug that into our calculator, it'll give us 30. So with a simple interest account, this $30, that's what we're going to be adding every year. So to the next year, we'll add 30, and to the next, and so on and so forth. So I can start filling out this table of this would be 530 in the account after year 1, 560, 590, 620, 650. So I didn't even really need to do much calculation. With simple interest, you can just find that initial or what you're going to be adding on for interest, and it stays the same year to year. Now, I'm going to give you the formula, but just to get an idea of where that formula comes from, let's talk about what calculations we actually did here. So this whole calculation of finding that 6% of 500 and then adding it on, just to break that down a little bit, that would be the same thing as writing out 500 plus 6% of 500. If you plug that into a calculator, it'll give you that exact 530 right there. Now I'm going to rewrite this a little bit just so that in general in math, when you want to see a formula, you kind of need to see a trend in the calculations. So I'm just going to rearrange it a little bit so we can start to see this trend. But it comes from factoring. So if you need a review of factoring, you can look it up. But with factoring, it's the idea that we have this common factor of 500 in those two terms. So what I could do is factor it out. And what I'd be left with, like with this first term, if I divided out of 500, I'd be left with the 1, plus if I divided out 500 from that second term, a 0.06. So I'm just going to leave it in that form so you can see a theme coming through with our next problems. With the next one, what we would have done in terms of a long calculation is we would have had 500 plus 6% of 500, and now I get us to 530. But then what we did for the second year is we added that on again. So really, in a factored form, I have this 500 factored out with a 1 plus a 0.06 plus a 0.06, and that would be the same thing in just a factored form. And then I'm just going to write it one more way of 500 with a 1 plus 0.06 times 2. So what this could read as is we have our initial amount of 500. This one is coming through as having 100% of that value. So we're keeping that $500 and then we're adding on 6%. But in this year two, we're adding on that 6% twice. Whereas that first year is that we were adding on that 6% once. And then if you can imagine I do it for this last one, it would be the same as year two. I would just go plus 0.06 times 500 again, which means in this factored form, I'd just be adding 6% on one more time. So I could even start to write it without showing that whole breakdown of having 100% of that 500 plus 6% of it. But for year three, I would need to have that 3 times. And then for year four, I would see that 4 times. And then for year five, oops, sorry, that was a 4 there, but it should be 6%, 6%, 5 times. So now I can start to see a theme so that if I wanted to jump to year 100 of this account, I would know what to plug in. I would still have that 500. I'd have 1 plus 0.06, and that year value would be plugged in right there where the 5 is with year 100 or whatever we want to look at, so that we don't have to actually calculate year to year to year. We could jump ahead if we wanted to. So for a formula, the pieces that are coming through is the initial amount that we deposit, so that principal. This will always be 1 right here because we always want 100% of that value and then adding on. And then this right here is the percentage rate that we're using. And then right here goes the year time. So what we want is a formula that deals with the principal, 100%, the rate that we're using, and the year. So for notation, what we're going to be using is A is going to represent the amount that's in the account, or you could think of this as the balance of the account. We'll use P for principal, so that initial amount that you deposit. R is going to represent the rate, which when you have this rate, they'll always tell it to you in percentage form. We have to use the calculations in decimal form. And then we'll have some passage of time, typically in years. And so how we calculate the balance of the account is following the form up above there. We'll have our principal, and then in parentheses we'll have 1 plus whatever the rate is times time. So this gives us a format that if we're dealing with simple interest, we can plug in the values and find the balance of the account. So let's look at an example with this. We are investing $350, so that's going to be our initial amount. And we're earning 5.8% interest every year, so that's our rate. And just be sure to change that to a decimal, which means pick up that decimal place and move to the left twice, or you could think of dividing by 100, but this should be a 0.058. And then for time, we have 12 years, and what we want to find is what is the balance of this account? How much do we have after 12 years? So what I'm going to do is plug in to the formula, so we'll have our principal times 1 plus the rate times the number of years, and we just plug that into a calculator and you should get 593.60. And with these problems you'll be getting dollar amounts out, so you can round to 2 decimal places and we'll have our units of money. So this isn't a very common form of account, but it's a good stepping off point for looking at compounded accounts, which is much more common, but this would be for simple interest.